So there's apparently still debate if black holes are actually real, even though in recent discoveries we even have been able to image black holes. There's still the core conversation about singularities actually being a real thing versus just a theory, and this debate spilled over in the comment section of one of my previous reaction videos, which is called "What Happens If You Destroy a Black Hole?" In there was a user named Sean0762 who created a very interesting argument where black holes are not real, it's really just time dilation. You could read it yourself. It's actually right here. So he says, there is no black holes. General relativity predicts dilations, not singularities. And he goes on to quote a journal entry from 1939 by Einstein. Einstein says, the essential result of this investigation is a clear understanding as to why the Schwarzschild was the first to raise the issue of general relativity predicting singularities do not exist in physical reality. So the argument is it doesn't really exist in the physical world that we live in. Right, maybe exists in the mathematical numbers and the theory in general, but in the real world, it does not physically exist, apparently. So this debate went on to go pretty deep. I replied, considering the advancements in observational astronomy since then, like the Event Horizon Telescope actually capturing a picture of a black hole, how do you see this development in light of his viewpoints? Even another commentator, Decomposed Corpses, excellent name, said, thank God this random YouTube commentator knows more than 1,000 astrophysicists. You should publish your findings immediately. I believe that was a very sarcastic reply. And Sean got back to me, he says, what we see in ultramassive objects is not giving off light. Dilation is the cause. Dilation is known fundamental phenomenon. Singularities has always been a stubbornly persistent fictional term. Nobody believed in black holes when Einstein was alive. His reasoning on why they don't exist is solid as a rock. So Sean really believes there's no such things as black holes, and the things that we're seeing in space are really just dilations. And yeah, and this conversation goes back and forth. I asked some more questions, gave me more responses. Other users jumped in again, asking questions, and it went on. And some people really did not like where this conversation was heading. Why are you spouting nonsense? Black holes exist. It cannot be disproven, right? That leads us into today's video. The video is called Iconic Black Hole Pioneer Disproves the Existence of Singularities. So apparently there's now some proof that singularities don't exist. Whoa. This is kind of crazy, right? Because black holes and singularities, they're intertwined so heavily that I don't know how you could have one without the other. This is a video by one of my favorite channels, Anton Petrov. Go check him out and let's get right into the reaction.
Today we're going to discuss black holes, and specifically the concept of singularity inside the black holes
and that's the whole debate we've been having, right? So
it was proposed back in 1970 by Stephen Hawking and Roger Penrose in the paper they wrote together that you can find in the description below. And in a nutshell, when applied to black holes, it basically means that once you cross the event horizon, you essentially reach a point where, well, first of all, there's going to be only one direction. I guess you can call it down. And so even if you try to move to the left or to the right, or try to, I guess, move up.
This is the whole concept of, time and space become inverted, like switch places.
You're still going to be going down at all times. And what exactly is down? Well, it's supposed to be that singularity. This animation by Andrew Hamilton sort of presents this pretty accurately. And in essence, it represents this point of infinity where everything sort of gets condensed into, I guess, nothingness or somethingness,
which is something in a lot of my reactions and videos about black holes where they say that in a singularity it's infinite curvature, there's infinite density. It's a lot of infinites going on, which makes it interesting. Mathematically, I see how it gets there from explanations some of the commentators made. Does math always 100% represent reality? That's the debate here.
But in essence, the math here breaks down, so it's unclear exactly what's going on here. But
that too. Essentially, when you say something is infinite, is that a cop-out? Because you don't have the answer. It's just like saying, I don't know where it stops, what the thresholds or the boundaries are of something. Then you call it infinite, right?
The assumption was that everything gets crushed and becomes this infinite something. But we
The other aspect of it, there's another video that talks about what does infinite mean really, and I'm gonna be doing a reaction on that for sure.
know that infinity generally only seems to exist in mathematics. It potentially does not exist in physical world.
See, oh, there you go, Anton. So he says, potentially infinite only exists in mathematical terms and not in the real physical reality, which is something I could see being possible. But I'm just a guy on the internet, doing reactions.
And so because of this, not a lot of scientists accept singularity as a concept and believe there are better explanations that we just don't have yet. And today we're going to discuss one of these explanations proposed by an iconic black hole scientist, a scientist that has an entire metric named after him, Roy Kerr, a mathematician from New Zealand who made a lot of intriguing propositions about
Now that's credentials, right?
black holes around the time the concept was born a few decades ago. And he was actually the first to realize that, well, these types of concepts only apply to black holes that are completely stationary, do not possess any momentum, do not possess any charge,
No spin, none of the spinning ones.
and most importantly, do not spin. And these Schwarzschild black holes make sense mathematically, but potentially not physically, and may not really exist in the actual universe. And that's because all black holes we've discovered to date will usually spin and are also expected to contain charge as well. And
So is Sean, the Sean commentator, is he half right? Like black holes exist, but singularities don't? Is that what we're getting to from here?
so he proposed the concept of spinning black holes that are now known as the Kerr black hole. Black holes that actually become a little bit more complicated and acquire additional regions. First of all, they acquire this really intriguing region known as ergosphere that we discussed in videos before, that in essence represents this very strange space-time region where you can never stay still.
Interesting. A space-time region where you never stay still.
Even if you try really hard not to move, it will make you move. Here, the space-time itself moves at faster than speed of light.
What? I thought it was not possible for matter or anything to move faster than the speed of light. The only way that happens is usually when new space is created in between 2 points, and the expansion of that space is faster than the speed of light for those 2 points. So this is adding something that breaks some other rules, right? Actually, is there any laws, physical laws, that say nothing can go faster than the speed of light? I know there's a lot of consequences of that, like breaking causality and stuff like that, but is there literally, because I know mathematically it says, oh, you need infinite energy to take matter with mass to speed of light, but then there we go again with the infinite problem, right? Infinite could just be a placeholder for we don't know, question mark, right? When it comes to the real world.
And intriguingly, inside this region, things can acquire so much kinetic energy that if they do escape from ergosphere, they'll actually leave with more energy than they entered. And as a result, it's been proposed to potentially serve as a kind of a infinite engine, or I guess the source of free energy. You can technically steal a lot of energy from these black holes, and you can learn about how this could be done by, for example, some kind of a advanced extraterrestrial intelligence in one of the videos in the description. More importantly, you would not be able to have just a simple circular orbit around these black holes. Nothing here orbits in a simple circle, and everything acquires these really complex orbits because of the spin of space-time due to the spin of the black hole. In other words, the black hole itself literally drags the space-time around itself, making things orbit in a somewhat spectacular fashion. In essence, all of this would lead to the formation of these enormous torus-like structures around black holes, with various particles orbiting in very hectic formations, interacting with one another.
That's a crazy orbit. You guys seen that?
Creating huge amounts of friction and emitting all of this as super bright light, which is sort of what we usually see from black holes to begin with. Once again,
that's really literally how we could even spot black holes, right?
This type of a simulation that shows us the disk as really perfect and really flat is not entirely correct. But I guess more importantly, today it's believed that pretty much all black holes, or at least all black holes we've discovered so far, spin, suggesting that all black holes are...
Hold up, so all black holes spin? I thought there was different types of spin. I mean, I guess maybe you could spin very slowly and very fast. So
at least Kerr black holes, not simple black holes that you see right here. And instead, this most likely looks kind of like this.
Inner horizon, there's multiple horizons. The orgosphere, we know about that. Ring singularity. So yeah, when you're spinning, there's the ring singularity instead of the point-like singularity.
And notice how now the singularity becomes something a little bit different. It becomes a ring singularity, or a ring-like structure that behaves in very different ways. But none of this is news. As a matter of fact, all of this was known for several decades. These are old propositions from back in the 60s and the 70s. But here's the thing. All these years, Dr. Kerr was actually thinking about all of this, and he finally made another proposition. A new paper simply titled, "Do Black Holes Have Singularities?"
Dun dun dun. Do they really exist? Is Sean, the commentator, correct? Have we gotten the singularity concept all wrong in real life? Find out in the next episode of
a completely new approach that suggests that in reality, in physical reality, not mathematical one, it's quite likely that singularities do not exist, and instead all black holes possess something entirely different. And so, hello wonderful person, this is Anton. Let's discuss this in more detail.
Hello wonderful person, this is Don Mecca. And if you haven't subscribed to the channel or liked this video, make sure you do if you enjoy interesting conversational reaction, commentary on these type of videos.
Discover what Kerr proposes and what his reasoning behind this is, and I guess in the process, learn a little bit more about black holes and what's inside of them. And so I guess first, let's establish the main difference between this and this. This does not spin, whereas the spin from this type of a black hole creates very powerful centrifugal forces that dramatically shift the entire geometry of the space and time around the black hole. It sort of turns it into a kind of an ellipse instead of a simple sphere. And it's these same forces that then form an unusual ring shape in the middle. And this is a result of the frame dragging effect that distorts the curvature around the black hole and even around the singularity. Which strangely enough means that if you were to ask someone to point at the center of this black hole and they were in different location around the black hole, they're going to be pointing at very different spots.
Ain't that true? That just reminds me of the Spider-Man meme where, they're pointing at each other.
More intriguingly, this type of black hole, unlike a simple Schwarzschild black hole, does not destroy everything in the middle.
Whoa. Everything does not get destroyed by entering the middle?
It's even been suggested that technically you could pass through this ring, making it act as a sort of a wormhole.
Whoa. Is this the key to faster than light travel? Or does that take you to a whole other universe? Jeez.
Now the math currently doesn't explain where exactly this would lead, but it might lead somewhere. Although practically speaking, it will be very difficult for a physical object to survive the tidal forces inside of this. Okay, maybe some kind of a subatomic particle might survive, but yeah, not you and I.
Right, you're gonna get torn the hell apart. It's like, unless someone manufactures a spaceship from strange matter that's in magnetars or something like that.
But in this new paper, the argument goes a little bit differently. It actually focuses on various light
No, actually, that would not work either.
Rays that enter the black hole and travel inside of it. Now, Roger Penrose and Stephen Hawking believe that something like this happens inside. Everything ends in the middle, creating singularity. But Kerr believes that due to the rotation of the black hole, not all light has to end in singularity. As a matter of fact, his new study proposes that there's not just one direction like in previous propositions. In other words, if the black hole is spinning, it's no longer just down. And here he demonstrates mathematically that certain light rays might actually be tangential to the event horizon and not even have endpoints and just stay inside the black hole indefinitely.
Oh my god. Trapped forever, just going where? Where are you going? If you're not heading to the singularity, where are you going?
Alternatively, some do have an end, but they don't have to end in the center of the black hole. In other words, in this new study, he makes a lot of different propositions for what can happen to various light rays, with many of these conclusions basically proposing infinite possibilities. They don't just...
There we go again with the infinite
all end up in singularity, and according to him, most of them don't have to end in singularity at all, with his overall conclusion suggesting that singularity is not required in a black hole. And so after
Okay, so this person, like Einstein, argues singularities don't have to exist. So Sean, if you're watching this, I'd love to hear your commentary on this. I mean, read your commentary on this and see what you think about this. Because I think you also were arguing that black holes don't exist at all, not just singularities.
60 years, he makes a new proposition which basically removes singularity completely. But more importantly, he combines physical observations from black holes, or essentially understanding that all black holes spin and all black holes possess other properties, with his previous propositions that usually involve a ring-like singularity at least. And so intriguingly, once you cross the event horizon here, according to him, it may become possible to travel in different directions inside the black hole as long as you stay between the ring and the event horizon.
And how would you control that? How would you control that? Oh my god. Do you guys like this version of a black hole than the other? Because the other one, all paths lead to the singularity. It's like time. Time goes forward. You go forward no matter where you're trying to maneuver yourself. You're going to keep going forward. Time keeps marching forward. And, you know, inside the black hole, space and time flip. So space is literally time, acts like time, where you keep going towards the singularity.
Now you still cannot leave the black hole, you're still stuck inside the event horizon, but it does become possible to...
There goes that faster than light travel.
Move between these two regions, possibly indefinitely. Singularity is not a must, and crossing the event horizon does not mean that everything has to end up in the center. And his argument overall is pretty strong. All of the previous assumptions from the last 60 years assumed a perfect classical black hole that just does not exist physically. Anytime black hole is grown from anything, be it a supernova event or some kind of a collapse of a lot of matter all at once, it will always acquire at least a little bit of angular momentum. And this results in a black hole that spins just a little bit.
So that means there is no stationary black holes, at least not massive ones, I guess, right?
At least. Even going as far as calling singularities nothing but dogma.
Damn. Sean, looks like you were onto something, Sean.
He also provides a few physical examples using different types of stars, but despite this idea of no singularity making a lot of sense, there's still, of course, a bit of a problem. We still have no idea what happens inside the event horizon, and are unlikely to have any answers about this until we find some kind of a new theory that connects quantum mechanics with relativistic theories. And
even if we achieve that, will we have any definite answers? Because nothing escapes black holes. Nothing apparently, except for Hawking radiation, but it's not really escaping because Hawking radiation is just new matter being created at the horizon and escaping that way. So it's not even matter that entered the black hole to begin with. So nothing escapes a black hole. How do you research and understand something that is a one-way trip?
And Kerr himself even states it in his paper that the answers are very likely quantum in nature. And he even goes as far as to say that once we find a way to explain this using quantum mechanics, no singularities will ever be needed ever again.
Damn. R.I.P. to singularities? No more singularities? You guys tell me in the comments, like, what do you guys think of this? You know, it seemed like singularities was like a very established thing, but apparently not.
Because once again, even though infinities and singularities do exist in mathematics, they don't seem to exist in real life.
He raises an interesting thing. Like, is singularity equal to infinity? Infinity equals singularities? Like, singularities equal infinity? Infinity equals singularities? Are they interlocked like that? You guys tell me in the comments.
Dividing by zero just doesn't seem to work physically. And so a somewhat intriguing train of thought and a very intriguing paper.
Right. Try dividing zero by whatever, or divide something by zero. In the real world, you can't do that physically. So what does that say about the concept of infinity in real life? Stay tuned for a video on that soon, for sure, because it's a very interesting concept, the whole concept of infinities.
6 decades after the original proposition for the idea of singularity, and something to think about if you're a black hole scientist, I guess. But for all us normies, I think this would only matter, I guess, if we found one of these black holes somewhere nearby. Because, as I mentioned in one of the previous videos, it technically is possible to extract energy from them, especially if they're spinning really fast. And there was even a paper relatively recently sort of describing this if one of these black holes existed somewhere out there in the solar system.
No need for Dyson swarms.
And we'll probably talk more about this in some of the future videos, because it is a somewhat intriguing and a somewhat possible explanation that can technically even solve the mystery of the still undetected dark matter. More about this in some of the future videos. Until then, thank you for watching, subscribe.
Thank you, Anton. Thank you for that. So, what do you guys think? Like, are they onto something? Singularities? Are they real or are they fugazi? Is it all imagination? Is it just stuff that makes sense on paper but does not exist in reality? Is it that, or do you believe singularities are real? Are they? Let me know and let's have that discussion in the comments. If you enjoy videos like this, make sure you like and subscribe to the channel. If you have any other videos that relate to this or black holes, space, astronomy, astrophysics, let me know. I might do a reaction to it. Just leave it in the comments. Thank you for watching. I appreciate you. Don Mecca out.